Right. Okay. Welcome everyone to the final session in this room of the Data Science Festival 2023. It's my great pleasure to be able to introduce Eduardo Contreras-Cortez from KPMG. He's a data science manager with more than 10 years of experience in the financial service industry. He's worked on development and validation of credit predictive models, credit scores, stress testing, and regulatory credit risk models. Currently, he's at KPMG, but in previous roles, he's worked at institutions such as Ernst Young, EY, Foremost, Lloyds Banking Group, and Citigroup. So over to Eduardo.
Thank you. Hi, thank you. I think hopefully everyone has been enjoying the event as I have been enjoying it. I feel that if this is a proper festival, I will be the closing act of this stage. But thank you so much. As I got introduced, I'm in KPMG right now. I've been working as a data science, focusing a lot into development of credit risk scores and all the tools around it. So banks, they use it a lot to provide credit and also to estimate capital, to estimate losses. So it's quite a big part of the everyday of a banking institution. And so this is about me. I want to make this one not the only one that I'm speaking. I have two activities. So let's start with the first one. And the first one, I want to get to know more about your data science modeling style. So let's suppose that we have a teacher here that arrives today, and he or she wants to have a model that can distribute 15 sweets to 30 children. So the teacher has a lot of data about the children, has all the demographics, the grades, the attendance, and basically he or she wants to develop this model so he or she can give these sweets to the children. So please let me know, how would you approach this problem? Any raise some hands? Any? Okay.
There's no way how you can distribute 15 sweets to 30 children, so she has to eat it herself.
One way, there is no distribution at all. That's one. Any other one?
You break the sweets into two.
Yeah, I have heard that one a lot, splitting the sweets so everyone gets happy, but no, unfortunately, we need to give the sweets entirely, and that means that there will be children without sweets at all. So another one, another volunteer. Okay. First come, first served. Hopefully the ones that will wake up late will for sure miss some sweets. Anyone? Compete. So compete. Another competition. Any other one? Allergies or health issues, yeah, you need to know more about them before giving them a sweet. Okay, another one, a couple more. Yeah.
Maybe some people don't like sweets, so like they don't need it, don't give them.
Yeah, you need to ask them if they want the sweet or not. Last one over there.
Alternatives, skipping one and giving them.
Kind of randomly, yeah, that's I like that way. That no one can blame the model. It was just random. But yeah, that's very good to know. I'm going to be covering some of the topics concepts that every day we do in modeling. And one, of course, is which type of model we want to build. So we mentioned like some rules in here, just define a rule, first come, first serve, a random one. But then obviously we have all the statistical models like regression, and now everyone is talking about machine learning. Also, of course, that's also a model. Also, we have mentioned so far a population. We have right there the children, but we just mentioned one class. It could be all the school. It could be all. We can build a model for all the UK schools. So that's another concept in modeling. What is the population that we want to build a model? Another very important, and that's one of the main topics that I'm going to be covering, is about the protected characteristics. So there are laws against discrimination. And the main concepts about the main protected characteristic is to care about gender, ethnicity, religion, and age. So that's something that we need to take an account when we're building a model to not discriminate against them. And then derivate to that one, the group, which one is the vulnerable group of each of these protected characteristics. So for example, there could be a female, or it could be the ethnic minorities. And the inferable outcome, and every model will have, is which one is the one that won't have the outcome of it. So in this case, all the children that won't receive a suite, that's the unfavorable outcome. So there will be children without suite, and that will be very sad about that. And obviously, we are data science people. We need metrics to measure things and to also to account on how our models are doing. And that's one of the topics that I will be covering in the next slide about how we can use these metrics to make sure that the models are, we can make sure that the models are not creating a big bias and discrimination. So this is about the children and the school, but obviously I'm not working in my everyday job to distribute suites with children. So in my everyday job, as I was mentioning, I'm in credit risk, developing all of these credit tools. And I'm going to cover today how my model went wrong. So I'm going to present you the data that I use and my model that I built for it. And this it's a very similar data set that I will find, that I will use on my day-to-day job. This data set comes from the Kaggle website that is probably quite famous in the data science community. So they publish data for people to compete and to build the best accurate models in there. And it's coming from a company, from Comcredit, that is quite a big company in Europe and Asia. And this specific data set is about a loan application data set. So it's people that have been going to request credit. And all of this data set is very rich in data. It's very similar to what I have used. It has data from all the sources, from demographics, for all the financials and all the bureau data that they have collected. In here also, it was quite a big data set. We have almost more than 300,000 observations. And the features, once I expanded it almost to 800 features. So it's quite a rich data set to use as a modeling. And as I was mentioning, the outcome is to predict which customer is going to be defaulting based on his historical data, which customer won't pay their loan. And obviously, from that model, we can build I use this model to see who we are going to give a credit. So this is a typical way that in the banks we develop the credit scores. We have the historical data of how people have performed and not paying their loans, and use that one as a tool to build and to decide who is going to receive credit or not. So yeah, I use this data, and I built my model, and I was quite impressed about my skills, because I got a very good score if I compare it to the first place. And obviously, I didn't get all the money that they offer into the first place, because first I entered very late the competition, and obviously I was very close. I was still under the first place. So I was very happy with me. I was like, yeah, I did a very good job. And obviously, I encourage everyone to give it a try as well. It's a very good learning path to try to experiment with a very good data set. But my model, I think my model is wrong, because I didn't understand anything about the model, how the model works. I didn't have anything about which biases it can have. I didn't know if it's fair or not. And these are the questions that obviously my manager will ask me every time if I build a model like this. And also the customer will ask me how your model is performing. But most importantly, also regulators for all the banks and institutions, they come and scrutinize this type of models of like credit scores to make sure that you are not discriminating, and that's part of the regulation. And just this week, it was a big news from all the banking institutions. There is a massive release from the Bank of England to put more scrutiny into this type of models. So it's going to be coming soon during this year live. So that's also quite, the Bank of England authorities are making more and more scrutiny into these type of models to make sure that the banks are using them properly. So that's what we're going to be covering. What is wrong about this model that I built, that I thought it would be very powerful? It was almost the first place, but no. I think there is something wrong in here. So let's take a look on it. So the way that I'm going to find the errors in this model is on the way that we develop the model. We have a classic modeling stages in here. But in each stage, there are different errors and biases that it can happen, and each of these errors can happen many times, and that errors will ultimately accumulate to have a very bad model, let's say. So I'm going to be covering these main topics of, most importantly, what are the questions that you can ask yourself, and what are the toolkits that you can use to find, to test, and to get a better model in that way. So the first, just before going to any data tool, just before starting to program in your Python, you need to start approaching you need to have a plan for it. And I think the first question that I always ask myself, because we're going to develop a model, we're going to have a solution that ultimately will have outcomes to the people. And the first big question is like, okay, I'm trying to solve this problem of who I'm going to be credit. And I think at the very first stage is like, who is going to be, from my population, who is going to be in that potentially discriminated. And I need to be conscious of that discrimination at all times to make sure that I'm not missing something out from this group that are potentially discriminated. Like, for example, female or ethnic minorities. It's something that even just before getting to the modeling, is something that we need to make sure that we account for it. And normally, this happens in every data set. For example, in credit data, and especially, for example, in this case, the data that I was using for the machine learning model, it had more males than females. So that's why it's a part of representation. So there is potentially someone missing the data that didn't manage to get access to request the credit for any reasons. I'm thinking, for example, if the only way to apply for a loan is through a mobile app, then what about all the people that they don't have access to a mobile phone to request a credit? So that's kind of the things, like probably there is someone missing from the data, and one of the things to check is before entering into the data, how we collected and how we got to that data set that it was built. And obviously, every data set has issues, and that's one of the things that also before getting your hands into your machine learning model, check how representative is your data set. One of the things that you can check, for example, is with ONS data, like just to get a sense of the proportions of your population that your model is focusing, age, distribution of ethnic minorities, gender. So that's a good parameter to see how imbalanced is your data that you are putting into your model. So these are the three main questions that just before starting to do any type of model. I have now the second activity. So let's see how you can use these questions to solve this next problem. So, and this is a problem that a mathematician received in 1943. It was part of the research group. And he received the data from planes that were coming back home after the battle. So they were returning back to the base. And this, the mathematician, Abraham Wald, he had the objective to find where to put more armor into the planes so they can last longer, they can survive. And he obviously, they cannot put armor everywhere because the plane will be very heavy, but they need to armor just in specific parts so it can last longer. So let's say, just a show of hands, where would you put the armor? Like we can see a lot of red dots. All of the red dots are damage that they have received by bullets or whatever. Where will you put the armor? Will you put it on the wings? Will you put it in the main body? Or let's say on the tail of the plane? Who will say the wings? No one? Wings, okay. Who will say the body of the plane? Body. Many will put on the body of the plane. And then the tail. Okay, we have body, mostly body, okay. But we need to ask the question, which is the data that we are missing from here? So we know right now that it's all the planes that have come back to base from the war, right? But we are missing all of the ones that didn't come. So eventually, the ones that got sunk, got destroyed, are somewhere, and we don't have that data of them. And one of the things that you can see here is that just near the motors, there is no red dots, right? So why is that? Why our data doesn't have those red dots in there near the motor and the propellers? Well, that's most probably because the damage that they got, it was in that section, and that's why they synced, or that's why they were destroyed. So we are missing all that data, that all of the ones that didn't make it back to base, and that most probably where they need to put more reinforcement, to put more where the bullets are not in there, because that's where is the most crucial part. That's if the plane gets hit in there, they won't come back. So that's kind of the question is like, what I'm missing from this data set that I have in here just before starting to go into the machine learning model. And on a side note of this question, on my model that I'm building from this Kaggle data set, unfortunately, I think this is a really bad thing of these data science competitions, that they just give you a data set that is already prepared, and there is nothing else to do about it. You just take that for granted. And also, like, they anonymize many parts of that data set in many cases. At least in this case, from the one that the one that I'm showing, they haven't anonymized anything about that. But mostly of them, they just anonymize everything, and you don't have any clue of what you're doing, and they're just focusing to get the accuracy right, which is good if you're trying to build a very, very predictive model, but it's bad because then you don't know anything about that model of how it works. So that's one of the things that unfortunately, in this case, you can just take for granted that that data set is good, but in every time, please make this question: who is missing from this data, and if my data is representative of the people that I will be applying this model, and focusing in those discrimination groups that they tend to commonly to be discriminated. So now we have the data set. Let's assume that is right, and then now let's check how we can evaluate this data set to make sure that our model is explainable and also check for fairness. And that's when we're going to be covering 3 biases that are normally you can check for a model to make sure that it's fit for purpose, and also that you can understand the model. So the first one, it's the aggregation bias. And I think in this question, the main one is, if my model, is it good? Is it not too simple or not too complex? And one of the techniques that I like doing here is through the use of reduce what is not needed in the model to make sure that it's as simple as possible, but predictive enough. One of the techniques that I'm using here is through the use of SHAPs. I think many people now today have mentioned about them. I find it very, very useful for any of the machine learning models that I build, because it's just very, very powerful in explaining the model. And if you can see here in the first part of the graph, I started with my big data set that is almost the 800 variables. That had everything, and that has all of the data in there, and obviously it was giving me that almost 80% of validation in my ROC. So I thought that was a very good model. But then once I started to analyze the model, I found that with the SHAPs, that there were so many variables that were not required at all, that they were not adding any contribution at all. So I could remove them quite safely. And as you can see, there is no reduction in the prediction of the model. And I carry on analyzing that second iteration of the model. So I started to try to remove as much variables as possible. And in that second stage, I analyzed the first, what were the most predictive variables. And they were coming age and gender. And I think this is one of the main risks of putting age and gender in your models, because if you put it directly in there, then they're going to be likely discriminating, because that's going to be one of your main drivers of your model. And obviously, that will drive a lot of the power for any type of model by using these type of variables. So I removed them in the second iteration. So that you will see that is a quite decent drop in the performance. And then after that, I carry on with doing this reduction of variables, and to make sure that as I was removing them, I was removing the ones that are the less powerful, to see up to what stage I can stay with still a good model, but not that complex with all of those variables in there. Because at the end, it's easy to maintain and easy to analyze and to understand. So based on this one, probably we can see that iteration 9 with 40 variables, something around those iterations, is still performing with a very good performance, and also with reducing from almost 800 variables to almost 40 variables, which is only the ones that are basically driving the model. So probably one of those is the ideal iteration to use. But we still need to go with the other biases that we can check to see if any of those models are good enough. So for the next one is the evaluation bias. And I think this is the main part of how we can evaluate if the model is fair or not. So generally, there are three definitions of three metrics of fairness that are commonly used. There are these three: equality of outcome, opportunity, and accuracy. Each of these three are very easy to compute through the use of the confusion matrix in every model that you build. And they cover different aspects of the discrimination. And for example, the equality of outcome looks about the proportions of your group that is discriminated, could be discriminated, and the groups that are not. And in the other two works in a similar basis. They get different angles of the discrimination. But unfortunately, if we want to maximize one, then the other ones will decrease. So there is a need to strike imbalance of how you track your model with these three measures, because ultimately you need to do a balancing act, because the moment that you maximize one, you decrease another one. So how does these three metrics look in all our iterations that we have? So I have here plotted, I have used gender as the one to compare for discrimination. And the same can go with age. You can analyze customers that are like a little bit more older, or like in vulnerable groups, or ethnic minorities if you have the data as well. So what we can see here is that the closest these two lines are better for your model. That means that your model is discriminating less with this, on gender. So we can see also like iteration 9 and 10, it's quite close. As you can see for my first model, that line was huge. And it was mostly important. It was mostly because it was using that age and gender pattern that is basically increasing the discrimination of my model in terms of age and gender. So yeah, the closest R is the best for my model. But let's assume that iteration 9, that model, it still has quite big gap in between these two lines. How can I know what is the main source of this discrimination? And that's also something that we can use through sharps. So in this learning bias, we can analyze which are our sources of the data set that is or variables that are creating this gap, this discrimination. So in here, I have first the most relevant variables in my model. And then with the use of sharps and this and how it can explain the model, you can find the disparity, in this case with gender. We can find what are the main contributors of disparity between gender. And we found that the time on employment is one of the biggest contributors. So that gives you tools to analyze further in the next steps what is wrong with this model, or especially with this variable. So I took a look on this one, and I found out that days of employment is very related to gender. Men tended to have higher time in their employment than female, and also men tend to be lower risk than female. So that creates that proxy of with this variable. So then the question is, is it okay to keep this variable or not? Well, that depends how you're going to be applying the model. So that's basically in how you want to keep your model, your final use of your model. Also, we can remove this variable, run the model again, and see how that disparity, if that disparity is fixed or not. But now at least we know what are the sources of this discrimination. So I really, I very useful these techniques of explaining the model and explaining the disparity that you can find with protected characteristics. So yeah, give it a look on that paper. It's very, very interesting. So now we have analyzed our model. We found that iteration 9 was better. We have made so much simpler the model. We have found that in terms of discrimination, is quite well balanced in all of the different metrics. And also we found that one of the main culprits of discrimination is with this time of employment, that we can decide to remove it and run the model again to find a fair model overall. So once you have the model, obviously, then the time comes to make it and make it use of it. And I also found that it's very important to make sure that your model makes, once it goes into the deployment, make sure that it's not they don't have any issues at implementation, because ultimately that's going to be keep scoring and it's going to be the main factor of how you is going to be taking the decisions. So make sure that the model is well implemented, and also monitoring how it will perform through time, because that's one of the main things. Like the models are not stable, population will change, drivers will change. For example, in the last years with COVID, with all of these cost of living crisis, in terms of credit risk models, all of them are changing the performance. So it has been very important to keep monitoring and see how it perform. If something goes wrong, try to find a solution on how to fix them with new data sets and with new data. So in summary, so we went to all of the biases that my model found across the many different stages of the model build. And with the tools of interpretability and with SHAPS, with the fairness metrics, we're able to find a more balanced model that can help us to have fair outcomes, a more interpretable model, and obviously solve my issue. And ultimately finding as well that not the model that performs the best is generally not the most suitable to use. So try to strike a balance in your performance and your fairness metrics and your interpretability of the model. Thank you. Just a small advertisement. I work in KPMG. We are hiring people from, if you are interested in credit risk models, come and let me know. This is my LinkedIn. Also, there is an Instagram of the team. Is women_who model. Also, I will be putting all of that into LinkedIn, and I will be sharing many of the relevant material that I cover in this presentation. So, any questions?
Thanks, Eduardo. Got lots of questions here. We'll start here.
Bootstrapping, does that help or limited?
Yeah, it's very limited, especially because with bootstrapping, you always try to use the same data set, so you don't change the representation of that data set. So ultimately, if you want to have a representation from the group that you are missing, ultimately you need to get that data to see, to incorporate that one in your model and avoid that, let's say, unfavorable group that has been misrepresented. So ideally, is go and get more of that data you are missing. And that's, bootstrapping, I will put it more into a technique to find confidence of intervals or something that it doesn't require representation of data.
Okay, next question, we had a few over that side.
Yeah, anyone from the side? No? So there was one, yeah.
Sure. Yeah. If you were dealing with like a stakeholder, how would you go about communicating that, maybe this model that includes protected characteristics could get you 90% accuracy, but if we remove it, we get 80. How do you kind of maybe make the case for being more fair in the way you do it at the expense of accuracy or performance?
Yeah, definitely. With the first thing is tell them that the regulators will come and see your model, and that's the thing, because then with more scrutiny, more use of machine learning and AI, they are coming more into make sure that the model is understandable, if the model is fair or not. And yeah, with this big release of the Bank of England and the PRA just this week, it's going to create a little bit more of moral scrutiny for all of those models that provide credit, that estimate losses, and to make sure that actually the banks are building models that are beneficial to the society as well. They know what they know that they are doing something good. Yeah.
Hello. Thanks, Eduardo. Are you suggesting that we do the evaluation bias statistics for all protected variables? So that could be age, gender, religion, region, and then look for proxies for those variables. I'm just concerned, obviously it can be quite a time-consuming exercise, which you'd probably need to automate. And then is there a danger you might be left with a model of about 5 variables that you can use?
Yeah, definitely. It's a time-consuming task, but it's something that needs to be done, especially because on those models that actually are having outcomes on people, And for example, in the side of credit scores, it is a must. In other models that are estimating losses that are internally, you don't need to run all the fairness metrics, but you need to run to have a simple model and to know what it's doing to estimate losses. But especially for those models that are sensitive to people outcomes, it's a must, because otherwise you can left out people, and that impacts. The children will not have sweets, let's say. But yeah, it's definitely a task that needs to be done for credit scores at least.
Are there ways, rather than removing a variable, to account for the differences in the groups in the variables, so kind of adjust the data rather than remove it?
Yeah, there's a lot of techniques to balance before the model and in processing in the model. But many of these techniques, they're going to play with the weights. So you're changing the weights of how the model will score. So I always check first if your model is representative enough, like your data store is representative enough before trying to do an imbalance. Because even the imbalance, you can just change the odds of things occurring, but you're not changing the representative of population. So it's okay to use these techniques. But then my other point is about the if any of those things, any of those adjustments that you do in your model, if you understand how it works in the model and the final estimate. So it's two things. Make sure that your model is, you understand how it works, how it scores, that is interpretable, and also that your data is representative enough after you are doing any of these changes. Is that answer your question? Or is it going on those lines? Yes? Yeah? Or we can chat later in the after talk, yeah.
Your bias, so it's always one variable. Have a cluster of variables.
Which one, sorry?
I mean, your kind of fairness is, well, okay, male, female, whatever else. What if two attributes cause the
in this one, it was the example of just gender. But generally, you check through all of them. That
meaning the correlation of two. So maybe it's gender, sex, gender plus geographic location. That kind of stuff. It's more the subsets of the clustering of a couple of attributes that cause the bias, rather than,
Yeah, you need to run across all of them. Like
I don't mean linear. I don't mean a linear kind of search. More that there might be attribute 1 versus attribute 2 or 5 is causing the bias, rather than just attribute 1 and 5. Non-linear things. Yeah,
there could be collinearity. Like there could be many variables that are creating that proxy to gender. Yeah. There are other tools from the SHAPS as well that checks heat maps of correlation. They're also very useful. It's like it presents a heat map of how the variables create that correlation. Mm-hmm. But the only thing is that let's say if you don't have age or gender in your model, then you don't know how is that correlation, that heat map. So that's why then you need to go with this other layer of using that one and against the other one. So try to create a correlated principal components or something like that that will try to address how much is differentiating with the age of gender. Yeah.
There are a few fairness toolkits that are out there in the market, like Fairlearn and the IBM ones. Have you tried using any of them, and are they what they say they do? Are they actually doing that? Do you have any recommendations of any of the toolkits? Yeah,
there's the IBM 360 fairness app toolkit. Sorry, yeah, they cover the same concepts, but they add another ones. But then some of them are very more complex to understand. The industry kind of follows on these three because it's easy to know how to tune it, how to find, how to understand it and find a balance on them. The other ones, for example, there is one called Manhattan Distance of Fairness. So like they do something more complex that is difficult to see, understand how it goes behind. So there are other ones for sure, but yeah, normally these ones are easy to understand.
Any more questions?
Thanks, Eduardo, for your talk. I guess a question I have is, what we can see from this data is that it's inherently biased. Even after reducing it to 10 features, you still have bias. So obviously, if we feed biased data, we're going to get a biased model. How can we get to the point that we get unbiased data? Because I assume when it was a human in the loop system, it was biased. Now it's biased because our models are biased. So when do we break that loop of biased data?
Yeah, normally for getting more data, you can test on, let's say you have that you have limited data. Then the only way to get more data is to try to get it. And normally banks also have the option to offer credit, let's say for 1% of the ones that got declined historically. So they start to acquire that data that falls below your approval, and then they get that representation from that missing groups. So that's the first stage of creating better, like fair models. Get that data that is fair, well, to remove that unfairness and build a model, because ultimately that's your raw source to build. Yeah.
Any more? No?
Thank you, Eduardo. So assuming you have the Kaggle competition where you can't actually change the data you have, could you instead design an evaluation score that penalizes you if your score is your result is containing biases? And do these techniques already exist?
Yeah, there are tools. That was the one that I mentioned, that in processing, they changed the account for unfairness. I haven't used that much those ones, because ultimately you are adding more complexity to your model build. So it's the process that I follow more is develop the model, analyze how it goes, and see the main culprits of unfairness. And then from there, remove them, the ones that you don't see suitable, because it's a mix of this is the result that you are expecting on the business sense, like removing variables that are age, gender, everything that it looks to be correlated with discriminating feature. Build a model, and you still see things that you don't expect to see, then remove them from the model until you go to that final one. Because it's a journey. Rather than trying to put everything into an algorithm to try to find and retune your model, it's going to, at the end, you're going to come at the end, like, at the end, I don't know what that model did, and now I have this model that I should use, but I don't know what was the process of that. I think just more the model complexity. Yeah.
Any more? Doesn't look like it. Okay, let's thank Eduardo again.
Thank you.